Good morning, everyone. Hope you're all healthy and happy after your spring break. Uh, we're going to be working on a interactive activity for engineering on how you engineer and design a heat pack. So heat packs work the same as the cold packs, which you're probably a lot more familiar with. Cold packs you get for a sports injury or from the nurse, where you squeeze together a pack, and when you do that, you're actually breaking apart the two packages that are inside, which each has a different chemical in them. And once they combine, they create a reaction, and that reaction either generates heat or it generates a cold. So in this case, we either have to absorb heat or we actually give out heat. So I'm gonna read the overview with you right here, and this is right on our HMH website. So I'm going to be assigning this to you, and you're going to open it right through the HMH website. If those of you who are still having trouble getting on, please make sure that you are using your Booten email address, spelling it all correctly, and your password is PASS, and your 5-digit student ID, which you can find right on Realtime. Okay, so overview. Heat packs help relieve pain from injuries. Several heat pack designs exist, some of which use a chemical process that releases thermal energy. The process begins when a user mixes substances together inside the heat pack or starts a change of state for the substance in the heat pack. You will evaluate two chemical processes that release thermal energy to design a new heat pack. So when something releases heat, we call that an exothermic reaction. If it absorbs heat and gets colder, that is called an endothermic reaction. So always think of it as the heat is exiting, and that is exothermic. Okay, so you would just close this window. This is exactly what you're going to see. So overview is where we just were, and up here you can see those tabs, and you can either X out or hit close. And now you are on your activity page, and there's two different tabs. This one is for magnesium sulfate, which you can see right here, magnesium, sulfur, oxygen. And this one is for sodium acetate. So remember, that doesn't always have to be in the front. So this is sodium acetate, which is carbon, hydrogen, oxygen, and sodium. So we're going to start with our sodium. Actually, no, we're going to start with our magnesium sulfate. So we'll see that here. So we were at sodium, and now we are at magnesium sulfate. And we're going to pick the first one, which is 7 grams. See the G there? So we're going to do 7 grams, and you'll see it show up here. And then we're going to select the volume of water. You have two choices, 80 or 90, and that is milliliters. So I'm going to select 80. And then we're going to select the room temperature. And I'm going to do it right in the middle. So that will be 25. Remember, this is in Celsius. So 25 degrees Celsius. You'll see that shows up over here on your graph. So remember what our criteria is. Cannot go above 52. It has to last for at least 15 minutes, greater than or equal to 40 degrees Celsius. And its temperature should be for room temperature, between 20 and 27, where we're starting it. And then our heat pack costs cannot be over $4. So my temperature here, you'll see room temperature 25, what we're starting with, and my heat pack cost is $3.65, so that's pretty good. All right, so I'm going to start the chemical process by clicking this button, and you watch what happens in this screen, and then after everything happens there, you'll notice that it will start over here. So we're going to start by looking here. Press start. You'll see that the packages are broken. They come in contact with each other and they have a reaction. And now we see that we started at room temperature. We go up. We are up over the 40 degrees Celsius line. And I've gone 5, 10, 15 minutes, but would it be a more than? It wouldn't even be equal to. So you'll have to see that that's a little too short. So I'm going to have to play around with this to try to figure out how much. So I have to change my numbers over here, change the mass. I may have to change the volume of water. And then I can also change, because I will have to make sure that it works between 20 and 27. So everything that I do has to work for all three of these. So that's what you're going to be doing. Whatever you do has to work at all three different temperatures for room temperature, what you start at. So if I happen to like what I've done and it makes sense and it works, I can go ahead and click Save to Notes. And that will go into my notes up here where it says Notes and Report. And I click that, and there is my table that I did. And I can add this to my report just by clicking that, and we'll bring it right over here. So this is your report that you're going to be answering questions on. And what you can do is you can actually, once you're all done with this, is highlight the entire document or save the document as a PDF, or put it in as a Google Doc, and then you can share that with me. But if we're not done yet, so we have to go back, and we would try a bunch of different other things with the magnesium sulfate. If you want to restart, all you do is do this little go back to the initial state. We just hit redo, and you'll see everything is blank again, and it's off of here. Now you want to try with your sodium acetate. Now we're going to say how much of a mass that we're going to be putting in there and what the room temperature has to be. So same thing here, same constraints. We're just looking to see which one works better. So you're going to go through this, figure out why it works. The evidence is your graph. So you have to show your graph. And then you're going to be putting that into your Google Doc. So you go back to your notes and report. You have to make a claim. So you would say, well, I believe that the either the sodium acetate or the magnesium sulfate would make a better heat pack because, and then you'd also have to explain how much you used of your grams and your milliliters of water and everything else in your temperatures, because you have to show that as your evidence and have your reasoning. And so it says it all here. So claim, evidence, and reasoning. Did you meet this design criteria? So that is your assignment. Make sure you put your name. Make sure whenever you submit a Google Doc to me that you're always putting your name, your last name in the title of your Google Doc, and you're always putting a header on it. Okay, that is extremely important. If you go to support up here, it gives you a rubric that you can look at. So there's your claim, your evidence, your reasoning, and your report quality. It gives you some learning tips, gives a user guide, background on what is actually happening, chemical reactions and processes. So take a look at these. They're there to help you, and I hope that you do all of that before you ask me any questions, because there is a lot of information there for you. So have fun with this, enjoy it, and write a little lab report for me. And this is a quiz grade. It's 150 points, and that will be due on Monday. Okay, hope everybody has a good week, and let me know if you have any questions in the workbook. Just you can either post a question on Google Classroom or send me an email. All right, take care, guys.